So this lecture is going to tell you about yet another way to solve a quadratic equation. And this is called completing the square. And I'll be honest, it's not one of my favorite ways, but I have to give all methods equal time, apparently. So first of all, let me rewrite this quadratic equation because apparently the format did not come through for the squared. So if I have ax squared plus bx plus c equals 0. Okay, I want to solve this quadratic equation. And here I've got this little illustration on completing the square. So you can see that you take b and you divide it by 2 and then you square it to get this little piece to complete the square. So essentially, I would want to take my equation, ax squared, and rewrite it with my constant term on the other side of the equal sign. I divide b by 2, and I square it, so I have ax squared plus bx plus b over 2 squared. And because I've added that over on the left-hand side, I must add it to the right-hand side. So I have c plus b over 2 squared. So let's do an example, because I think examples probably make more sense than the letters. All right, let's say that I had a problem that was x squared minus 12x plus 4 equals 0. And I wanted to solve for x by completing the square. First thing I would do is I would move the 4 to the other side of the equal sign. So I'd have x squared minus 12x equals negative 4. Now I need to complete the square on the left-hand side. So to find out what I'm going to square, I identify that b is indeed 12. So I want to divide 12 by 2, which gives me 6. So I get x squared minus 12x plus 6 squared equals negative 4 plus 6 squared. So I have x squared minus 12x plus 36 equals negative 4 plus 36. And I recognize that this is a perfect square trinomial. So I get x minus 6 all squared equals 32. And now I can go about the business of solving for x, which is I take the square root of both sides. That's plus or minus, of course. So I have x minus 6 equals plus or minus the square root of 32. Add 6 to both sides. Oh, hold on. That's a 2. 32. I add 6 to both sides, and I get x equals 6 plus or minus the square root of 32. And 32 can be reduced to x equals 6 plus or minus the square root of 16 times the square root of 2. So now I can simplify the square root of 16 to 6 plus or minus 4 square root of 2. And now I'm done. So that example I gave you was if the coefficient, the x squared coefficient was 1, but what do we do if our x squared coefficient is greater than 1? So let's do an example. Let's say I have, changing colors here, let's say I have 2x squared plus 8x plus 14 plus 14 equals 0. Well, I want to make my coefficient in front of the x squared 1, so I am going to divide by a. So if I divide everything by a, I'm dividing everything by 2. And I get x squared plus 4x plus 7 equals 0. So now I subtract 7 from both sides. I get x squared plus 4x equals negative 7. Well, b equals 4, so I would have divide b by 2. So 4 divided by 2 equals 2, and so I will add 2 squared to both sides. So I have x squared plus 4x plus 2 squared equals negative 7 plus 2 squared. And that gives me x squared plus 4x plus 4 equals negative 7 plus 4 is negative 3. This is a perfect square trinomial. X plus 2 squared. X plus 2 squared equals negative 3. So I have to take the square root of both sides. Ah, look, it looks like we'll have an imaginary answer. So I get x plus 2 equals the square root of negative 3, or x plus 2 equals I square root of 3. Subtract 2 from both sides. Oh, what did I forget? I forgot the plus or minus. So my answer turns out to be x equals negative 2 plus or minus I square root of 3. Completing the square can help us convert a quadratic function from standard form to vertex form, and I will give you an example of this. So let's say that we have the quadratic function y equals x squared minus 10x plus 22. Okay, I'm going to rewrite this as y plus something equals x squared minus 10x, and then I'm going to, so negative 10 is our b, divide it by 2, gives me negative 5, I square that, and I get 25. So this would be, excuse me, plus 25, add 25 here, so there's our perfect square trinomial, plus 22. Okay, so now let's write this as the binomial. So it's x minus 5 squared plus 22. And now, to put it in vertex form, I just subtract 25 from both sides. So I get y equals x minus 5 squared minus 3. So if I had to graph this equation, I would know that my line of symmetry is at x equals 5, and the vertex is on my line of symmetry at the 3. I know it opens up, and if I wanted to actually graph this, I could plug in, well, what's y when x equals 4? Well, I have 4 minus 5, which is negative 1. Negative 1 squared is 1. 1 minus 3 is 2. Negative 2. So I would have a point right there, a matching point on the other side, and I could graph that bad boy. So, some problems for you to try. Let me see here. We'll do x squared plus 6x plus 4 equals 0. So complete the square to solve that. We will do 3x squared plus 12x minus 18 equals 0. The dog's outside barking to come in. And then the last example I want you to do is I would like you to put this in vertex form. Y equals x squared minus 8x plus 17. All right. Put in vertex form. All right. Good luck, and I will see you tomorrow.